definition of a trapezoid. It is a quadrilateral. So we have a quadrilateral with exactly one pair of parallel sides. Okay, so it's exactly one pair of parallel sides. So like over here, I kind of extended all the sides. So let me show you why I extended the sides. All right. So over here, I've got this trapezoid. I have exactly one pair of parallel sides. My parallel sides are AB and DC. These are called your bases. Okay, you have to know what the parts are. So my bases are AB is parallel to DC. Now, with the bases come base angles. Okay, the base angles are the two that are next to each other. For example, A and B are base angles to base AB. D and C are base angles to base DC. Does that make sense? Okay. So now, your legs are the non-parallel sides. So like AD is a leg. So AD is a leg. And then BC is a leg. They're not necessarily congruent to each other. Okay? This is just your everyday, ordinary, run-of-the-mill quadrilateral. That's a trapezoid.
Wow.
Okay? One pair of parallel sides. And then you have the legs that are non-parallel. Okay? Now, if the legs are congruent, then it's isosceles. Okay? If the legs are congruent, then it's isosceles. Well, guess what? If the legs are congruent and it's isosceles, then that means the base angles will be congruent. Just like in an isosceles triangle, the base angles are congruent. Do y'all remember that? So that means, let's label this W, M, H, S, because I'm creative. All right, so what I do know is that WS is congruent to MH, because those are my legs, and my legs are congruent. Therefore, angle W is congruent to angle M. So this one is congruent to this one. I also know that angle S is congruent to angle H. So this one down here will be congruent to this one down here. All right, now the fun part. Since I have parallel sides, so and this is what I did is I extended, I said, okay, DC is parallel to AB, and I extended the sides because what's going to happen here is, why does it do that? I need to lock it. Let me see. Let me just lock that where it doesn't move. All right. We'll solve that problem. All right, now this side over here, what is it acting as? A transversal. So if BC is a transversal, then what does that tell me about angle B and angle C?
They are equal to 180.
Why are they equal to 180?
Supplement.
But why are they supplementary? What? Same side interior angles. They're same side interior angles. So that means that angle B plus angle C equals 180. Well, if that's the case, is it going to work on the other side also? Yes. Now AD is going to act like a transversal. So then that means that angle A plus angle D equals 180. Does that make sense? Okay. Now, in an isosceles trapezoid, it's the same thing. Angle W plus angle S equals 180. Angle M plus angle H equals 180. But there's an added bonus in an isosceles trapezoid, because opposite angles are supplementary. Because if these two are supplementary, then these two are supplementary, because aren't these two equal? So these two would also be supplementary. So also, angle M plus angle S equals 180, and angle W plus angle H equals 180. Okay, so just a little added bonus there. Questions? All right, are you ready? So what I want you to do is plot your points and draw your trapezoid. I already have mine plotted and drawn because I can barely see the lines on that thing. So what we're going to do is we're going to show that it is a trapezoid. And remember, to be a trapezoid, I have to have one pair of parallel sides, right? Well, how do you know if the sides are parallel on a grid? Same slope. So what we're going to do is find the slope of all of our sides to see if any of them are the same. That way we know if it's parallel. So remember, the slope of a horizontal line is 0. The slope of a vertical line is undefined. So now the slope of this one. So let me Q. Wait, 0. No, this one's Q. Q R S, and then that's T. This one is T. All right. So what is the slope of QT? Well, if this is 3 and this is 3, that's 3 over 3. So the slope of this one is 1. And then the slope of RS, well, I'm going to go up 6 and I'm going to go over 6. So the slope is 1. Well, then that makes QR or SR parallel to QT. So slope of RS is 6 over 6. Slope of QT is 3 over 3. So that equals 1. That equals 1. So it is a trapezoid because SR is parallel to QT. Now to determine if it's isosceles, the legs have to be the same, which means they have to be the same length. So if I count this, 1, 2, 3, count this one, 1, 2, 3. I love it when it's vertical or horizontal because I can just count. When it's slanted, like if I wanted to know the length of this one, I would have to do Pythagorean theorem. So now I know that ST is 3, QR is 3, so ST is congruent to QR. Therefore, it's isosceles. All right. Now here at the bottom is just two theorems. Do y'all remember when we did if P, then Q? This one is if Q, then P, because it's the converse. Okay. So basically this one says if you have an isosceles trapezoid, then base angles are congruent. This one just said, well, if you have congruent bases or base angles, then it's an isosceles trapezoid. So one way or the other, it still means the same thing. All right. Another property of a trapezoid is that if it is an isosceles trapezoid only, the diagonals are congruent. So think about it. You've got this angle equals this angle equals this angle, this leg equals this leg, now this diagonal equals this diagonal. They don't bisect each other or anything like that. They're just congruent. Okay? So now,
If we have one for the whole one, we just have to divide by 2.
say that one more time.
So if like angle A, if that whole thing is like 180, we just have to divide by 2.
If this whole angle,
Yeah.
the whole angle can't be 180.
I mean,
Don't, that's a bad example.
okay, well, it's 58.
Okay, if this angle was 58, then this one would be 58. Then how do you get this one? Well, what do you know about those two?
Because you gotta add them up.
They are supplementary.
They divide.
So then you would do 180 minus 58, which is 122. So this angle would be 122. So this angle would be 122. Now to find the length of the diagonal, that's, you just have to use what's given for that. There's nothing about the diagonals is half. The diagonals are equal to each other. So now go down here. We know we have an isosceles trapezoid because these two tick marks tell me the legs are congruent. So that means that M is congruent to L. Well, if M is 23, what's L?
23.
23. So since it's trapezoid, that's isosceles, these two angles are also congruent. So what do we know about M and J? So M plus J equals 180 because they are same side interior angles. So if M is 23, then what's 180 minus 23? So that means this angle is 157. So this angle is 157. Okay?
Okay.
All right. Now, do you remember when we did mid-segments and triangles? Remember that? The mid-segment of a triangle. How did I know that's a mid-segment? How do you know if it's a mid-segment?
It's the middle of the.
It what? Somebody started it over here. It connects midpoints. This is a midpoint. This is a midpoint. A mid-segment is a segment that connects midpoints. It is also parallel. And remember, the mid-segment was half of the base that it was parallel to. Now, what about the mid-segment of a trapezoid? Well, it still connects the midpoints. This is equal to this, so that's a midpoint. That's equal to that, so that's a midpoint. The mid-segment is still parallel, but this time it's parallel to two bases. So then you have to do the average of the bases. So base 1 and base 2. So base 1 plus base 2 divided by 2 equals the mid-segment. Which, think about it, if you only had one if you only had one base, then it's just half the base. But if you have two bases and it's in the middle, doesn't it have to be the average? Okay. So over here on number 4, using that thought, you've got your base 1 plus your base 2, and I'm looking for the mid-segment. So you add the two bases, 12 plus 36 divided by 2. Well, 48 divided by 2 is 24. So my mid-segment is 24. Easy peasy when they give you the bases. But what happens when they don't give you the bases?
Oh, wait, you gotta go backwards.
You gotta go backwards. You still use the exact same formula. The formula is the formula for a reason. So here I would do base 1 plus base 2 divided by 2 equals the mid-segment. So I would just need to multiply both sides by 2. So if I multiply this by 2 and then multiply this side by 2, now I have x plus 0.6 equals 3.6. We'll subtract 0.6, x is 3. So that means the base of this one is 3. Same exact concept. The concept doesn't change just because it looks different. And that also applies to number 6. Okay, what if I give you all this information there's no numbers there's numbers, letters, expressions. So you do the same thing. The base 1 plus base 2 divided by 2 equals the mid-segment. Plug the information in to where it goes. So now I've got 4x plus 14 divided by 2 equals 3x minus 2. So again, I'm going to multiply both sides by 2. So if I multiply by 2, it cancels. Multiply this side by 2. Now I've got 4x plus 14 equals 6x minus 4. Now you just do your basic algebra. Oops. So if I subtract 4x from both sides, what's 6x minus 4x? 2x. Add this 4 to both sides, what's 14 plus 4? 2 times what? Gives me 18. So x is 9. All right, so now I'm going to go up here and plug it in. So what is 9 plus 11? 20. What's 3 times 9? Minus 2. What's 3 times 9? Plus 3. Well, what is 20 plus 30?
50.
What's 50 divided by 2?
Well, you said 60.
25. All right, here we go. Now we're going to find the length of the mid-segment that's in example 1, so the one that was on the grid. Okay, so go back to the grid. So go back to the grid there. So we're going to find the mid-segment. Well, remember the mid-segment is base 1 plus base 2 divided by 2, right? Well, I need to find the lengths of these slanted sides. So remember what I said a while ago. Is basically what you're doing is you're going to use your rise and your run. Because if that's 6 and that's 6, then can I do 6 squared plus 6 squared? And it gives me the hypotenuse, which is the long side, right? All right, so this one over here would be 3 squared plus 3 squared, and then take the square root to get me that one, right? Yes? Okay, so y'all are going to have to help me remember. All right, so we've got 6 squared plus 6 squared equals c squared. 36 plus 36 equals c squared. 72 equals c squared. Take the square root of both sides. 8.5 equals c. Yes, no, check.
Yes.
All right, so the long side, that long one, what's the name of the long one? No, what's the name on your picture? What are the 2 points? What are the points? The name. RNS. RS is 8.5. Now I need to find the other one, which was QT, right? Okay, so QT was 3 squared plus 3 squared equals hypotenuse squared. 9 plus 9, 18. Take the square root of both sides, and it's 4.2. So QT is 4.2. Well, isn't that base 1 and base 2?
Yes.
So base 1 plus base 2 divided by 2 equals the mid-segment. So that's 12.7 divided by 2. So it's like 6.35, I think. Is that what it is? Double check. So that means that your mid-segment is 6.35. All right, kites. Yes, a kite is an actual figure. A kite is a quadrilateral. It has 2 pair of consecutive congruent sides, but opposite sides are not congruent. In other words, when you look at this picture, consecutive is these 2 sides. So CB and BA are consecutive and they're equal. CD and AD are consecutive and they're congruent. The diagonals are perpendicular, so that means you have 4 tiny right triangles when you have a kite. And angles are opposite. Okay, so we have exactly one pair of congruent angles. So angle C is congruent to angle A. But B is not congruent to D. So C is congruent to A, but B is not congruent to D. Now, when you draw the diagonals in there, because you had to draw them on yours, this diagonal here, it bisects the kite. Okay, so triangle BCD is congruent to triangle BAD. So it's basically a line of symmetry. Okay. Also, this triangle here is congruent to this one here. So now we've got triangle C, let's name this E. So CEB, so triangle CEB is congruent to AEB. Then we have this bigger right triangle and this bigger right triangle. So CED, triangle CED is congruent to AED. So basically what happens when you draw the diagonals, you get the kite will be divided into two congruent triangles. Then when you draw the other diagonal, you get four right triangles. Two are congruent to two, and then the other two are congruent. Now you also will get, you're going to get this triangle here. What do y'all notice about this triangle right here, ABC? It's not equilateral. It's isosceles, because this side is equal to this side. So it's isosceles. Then you get this isosceles triangle on this end. So you get two right triangles congruent, two right triangles congruent, top and bottom or opposite sides of the longer diagonal congruent, and then you just get these two random isosceles triangles. So there's a lot of congruency in here. So let's see if you can figure this out here at the bottom. If I want to find angle K and L, well, how many degrees are inside of a kite? Okay, so there's 360. Oh, let me get the pen back. Okay. So there's 360 degrees inside. So that means that 130 plus 90 is 220. So 360 minus 220 is 140. Okay, but the only problem here is there's two missing angles. So how are we supposed to know how much goes to each angle? How much goes to L? How much goes to K? Why are we dividing by 2?
Because when you draw the line,
Because if this side is equal to this side, then that means this is your diagonal. That's the line of symmetry. So therefore this angle is congruent to this one. So if you divide by 2, you get that each angle is 70 degrees. So once you determine which two sides are congruent, then the line of symmetry will go between them. Does that make sense?
yes.
All right, over here, remember this is the line of symmetry because this side is equal to this side. So that means this piece of the diagonal is congruent to this piece of the diagonal. So 1 over 10x minus 1 is equal to 9. So if I add 1 to both sides, I get 10. And then if I divide by this 10, I'm sorry, multiply by this 10, I get that x is 100. Okay, so that's just a few examples. So